Hey there, friends. I just wanted to go through the homework that you've got tonight. Some said they were having some struggles, so just want to show you the first problem. Here's the answer key. And I wanted to show you how I rewrote it, just the factoring, to get a sense of reminding you about what the graph looks like. So here I have points of intersection at 4, intersection rather, and at -2. So those are the roots of my equation. Here, this x equals 4, x equals -2. Those are the two places where it's going to cross the x-axis. And then it's asking about when is it increasing. Well, if you just look at the graph, we're just looking at the blue graph here, it's increasing when the y values are getting bigger, right? So it's increasing here, the y values are getting bigger. So that's where the graph is increasing, and it's decreasing here. Notice I'm going down, 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 down. So it just stops right there. So this is where it's decreasing. And you learned this back in pre-cal or algebra 2, this idea of increasing and decreasing. So I just wrote it here using functional notation. And if you go to Desmos and you just click on here, here's my graph, and you just click on this point right here, you've got that x value is 1, -9. So we usually talk about increasing and decreasing with respect to the x values. So we just have here that x, that's where the 1 comes from. So this is the point 1, 9. So the graph is increasing from 1 up to infinity, and it's decreasing because this will go out, it's coming in this direction and will keep going, and it's decreasing from -infinity to 1. What I want you to notice here is that if I were to take the derivative here, I'm looking at when is this positive? Well, here it's positive right here at this point. Here's where my graph is positive, right here. This is all positive. And down here is where the graph is negative. And what I'm trying to get you to see is that when the derivative is positive is the same place as when the slopes of the tangent lines where the function is increasing. So when I have positive, the derivative is positive, my function is increasing. When my derivative is negative, my function is decreasing. Okay, so that's the connection I'm hoping that you're going to be making. Let's take a look at the next one. So here's the red is the graph of the function, and then the blue is the derivative. So I just factored this out, and I factored it because if you factor out the -x, you're left with x squared minus 4, and that gives you a difference of 2 perfect squares. So you have here the intercepts at -2, 0, and 2. So just, making that connections. And then when is it increasing? Well, if you were to actually solve for this and look at the values, I have the exact values there. But what I wanted to also show you is that if you just go to Desmos, all right, and we click on the points here and there, okay, so that gives you your x value. So let's go back to, so that's how you just get those values. So where is the graph decreasing? So let's use our purple to show decreasing. We'll use this purple. Well, the graph is down, 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 down. It's decreasing until it gets to there. And then it's decreasing again over here, right? Well, where is it increasing? It's increasing. That's where I'm going up, okay? Oh, those colors are a little too close together, so why don't we pick this green here, okay? So that's where it's increasing. And what I'm trying to get you to see is here's the interval for its increasing, -1.5 to 1.5, right between these two values. There's -1.5 and 1.5. And it's decreasing from -infinity until you get to that value. And remember, this is unioned with, so coupled with the -1.5 to infinity, okay? If you were to take the derivative, 3x squared plus 4, you get this parabola over here. And what I want you to see is, well, the graph is positive here, and then it is negative down here, okay? And those are the same places where the graph is decreasing, and for the purple, decreasing is where the derivative is negative, and it's increasing when the derivative is positive, okay? Last one to go through. We're going through the exact same thing again. I did factor it again for you just to help you see where the roots are, but it doesn't matter if you know that or not. Well, you should. And then we're just associating the graphs, okay? So, again, decreasing, decreasing. Those are the two places it's decreasing. And look at where the derivative is negative. The derivative is negative here, and it's negative there. Look how they're connected. It's the exact same values. When the derivative is negative, the graph is decreasing. And then let's look at where it's increasing. So here it's increasing. Sorry, here it's increasing and the derivative is positive. Again, the graph is increasing, the derivative is positive. Okay, that's all we're trying to get you to see, and you can just graph these on Desmos and get the points, all those points, right off of the graphs. All right, my friends, I hope this helps. Have yourself a great day.